Hi, and welcome to Modeling Problems. Today we're going to be talking about word problems specifically that require solving a linear equation. And just like most modeling problems, it's really important to really attack these problems having a strategy. And the first kind of general strategy that I usually give to students is that you need to understand the problem. And I'm not talking about just the math. I'm talking about what's the context of the problem, and do I understand what they're asking me to find, what they are telling me is given, okay, and how we can kind of start constructing even maybe a drawing of the problem to really help us understand what's going on. The next thing is to really take what we are given and what we don't know and translate it into some kind of equation. Then we're going to solve the equation, and then you interpret the meaning of that equation. Okay. So I do have quite a few different problem types. But the first thing that we need to discuss are kind of words that are attached to basic math operations. Okay, so I do have a list here. I don't know if you want to screenshot it, write it down, pause the video and write it down. But these are some of the basic ones. One that is not in addition that I definitely want to make sure that we add on here is more than. That's definitely one that is very present. And I'm going to star that one as well as less than. Usually these two, whenever you have them together, whatever comes before and after usually end up getting switched around. And I'll show you an example of that in a minute. For example, if you have 3 less than 27, what that really means is this means negative. And then I'm going to take the 3 and the 27 and I'm going to have them switch places. So actually you're going to have 27 minus 3, which is actually 24. Okay, so that's why those two have to be starred. Something else that I want to add into the multiplication column or box is doubled. That means times 2. Tripled, so times 3. Okay, something for division like halved. That's times 1/2 or divided by 2. Okay, so keep that in mind. So let's go ahead and tackle some that actually have these in there. So again, I think it's very important to annotate every single type of problem that you have using these, okay? So example 1, if 4 is added to a number and the sum is tripled, okay? And I like to stop at kind of every punctuation mark. So what do I have here? I have that 4 is being added, so plus, to a number. A number represents my variable, which is x, okay? So if you want to highlight it, that's what that means, x. Okay, so 4 is being added to some number, and the sum, so that sum, this whole thing is being tripled, so times 3. So what does this look like mathematically? I have 4 plus some number x, and that's being multiplied by 3. Okay, the result means equals. Some other words that mean equals are, so the result, the word is, like 4 is x, that means 4 is equal to x, is equal to, okay, that's a basic one, but the result means equals. 16, so we have a number here, 16 more than, this is one of our starred ones, the number. So again, the number we're talking about is x. That's my variable. Okay, so we're going to have more than, which is a plus, and what we need to switch these two around. So again, result means equals. We have 16 more than a number, so x plus 16, okay, and then it says find that number, so we need to find x. Now, before we actually go ahead and solve this, look how much work I actually did for this problem. Okay, look how much annotation I did for this problem. So make sure that that is something that you are doing in your own piece of paper. So first things first, I'm going to distribute the 3. So I have 12 plus 3x is equal to x plus 16. Now I'm going to get the x's on the same side. So I'm going to subtract x from both sides. That cancels, so I have 12 plus 2x is equal to 16. I'm going to subtract the 12 from both sides. That cancels, and I'm going to bring it back up here. Okay. And then I have 2x is equal to 4. Divide both sides by 2. So x is equal to 2. So find the number. The number is 2. Okay. Now for time's sake and with how much we do have to get done, I am going to skip this next problem. However, if you want to pause the video, okay, do it yourself and check it with the teacher, okay, we absolutely can do that, okay, but I am for time's sake just going to move on. Okay, so Ginny and her classmates formed a study group. The number, so I stopped there, there's no important information, I'm good. The number of girls in the study group was 3 more than, so 3 more than, that's going to switch with whatever comes after, and then we have twice the number of boys. So before we keep going, now we're not just saying a number or like 11 or 12 or whatever it is. We actually have variables now. So I'm going to say G is going to equal the number of girls. And I'm going to say B is going to equal the number of boys. Okay. This is what we call defining our variables. I'm sorry. So I'm going to have 3 that it's being added on to twice the number of boys. Twice means times 2. Okay, so I times 2 the number of boys. So what do I have looking, what am I looking at right now? I have 2 times the number of boys plus 3. Okay, remember they switch. Okay, now it's saying there were 11 girls in the study group. So I know that since this is equal to the number of girls, and I'm also told that the number of girls is 11, I'm going to set 2b plus 3 equal to 11. And then we need to figure out how many boys there are. So I'm going to subtract 3 from both sides. I'm going to have 2b is equal to 8, and I'm going to divide both sides by 2. So b is equal to 4. We can always go back and check by plugging 4 back in to make sure that I'm getting 11. So 4 times 2 is 8. 8 plus 3 is indeed 11. So we did this right. Now what does this mean? This means there are 4 boys in the study group. So clearly these poor gentlemen are outnumbered. Okay, let's see here. Next example, a minor league baseball team plays 97 games in a season. If they want, so now we're talking about winning and losing. Okay, so the baseball team won, so that's the number of games won. L is going to equal the number of games lost. Okay, So I know that I have 97, and that has to equal the number of games won plus the number of games lost. So if the team won 16, more than twice as many that they lost. So more than, that means to say this 16 switches with whatever comes after. And it says twice as many games as they lost. So 2 times the number of games that they lost. Okay, and that is going to equal the number that they won. So I'm going to say winning is going to equal 2 times L plus 16. Now I need to determine, and I'm actually going to write it down here just to keep ourselves a little bit organized. Knowing all of this, I need to determine how many games they won and how many games they actually lost. So I know how many they won, and I have that in our other equation. So I'm actually going to substitute, I'm going to evaluate by plugging in this expression into the W. So I'm going to have 97 is equal to 2L plus 16 plus the number of games that they lost. So I'm going to combine my like terms, which is 3L plus 16. I'm going to subtract 16 from both sides. So this is